Welcome to another video. We have a math Olympiad problem before us. We have x minus 5 raised to the power of log, open parenthesis, 5x minus 25, close parenthesis, is equal to 2. We are to find the value of x. So let's begin. So here we have x minus 5 raised to the power of log. Okay, here we are going to factor out 5. So we will have 5x divided by 5, we will be left with x, minus 25 divided by 5, we will be left with minus 5. And this is equal to 2. We are going to make a substitution. Let x minus 5 equal to m. Okay? The equation will become m raised to the power of log 5. M times 5 will give us 5m. And this is equal to 2. Now, let us take the logarithm of both sides of the equation. This power, log 5m, will come to the back. So we will have log 5m times log m is equal to log 2. Here we have log 5 times m. We are going to apply multiplication law of logarithm. Okay? We are going to apply this law here. So log 5m will become log 5 plus log m times log m. And this is equal to log 2. Now, let us multiply what we have in the parentheses with log m. Log 5 times log m, that will give us log 5 times log m. Log m times log m will give us log m squared. And this is equal to log 2. Again, we are going to make a substitution. We are going to represent log m with a variable. Let us consider variable k. So here we have log 5 times k. So I will say k log 5 plus, and here we have k squared. And this is equal to log 2. Okay, you will notice that this is in the form of a quadratic equation. Okay, let us equate everything to 0. We are going to use a quadratic formula to solve this equation. So this is the quadratic formula. A is the coefficient of the first term. So A is equal to 1. B is the coefficient of the second term, log 5. C is minus log 2. Now, the next step is to plug these values in the formula. All right. Here we have k is equal to minus log 5 plus minus. So here we have log 5 squared. I am going to rewrite it as log 10 divided by 2 raised to the power of 2. Okay, 10 divided by 2 is going to give us 5. Here we have minus 4 times 1 will give us minus 4, and minus 4 times minus log 2, that will give us plus 4 log 2 divided by 2 times 1 will give us 2. The square root of, here, if we apply the division law of logarithm, we can express this as log 10 minus log 2 raised to the power of 2 plus 4 log 2 divided by 2. The square root of, here log 10 is 1. So we will have 1 minus log 2 raised to the power of 2, then plus 4 log 2 divided by 2. Here we have open parenthesis 1 minus log 2 close parenthesis, raised to the power of 2. This represents an algebraic identity. Okay? If you look closely at what we have here, we have open parenthesis 1 minus log 2, close parenthesis, raised to the power of 2. This represents the left-hand side of this algebraic identity. We are going to express this in this format. Okay? So here, 1 is represented by A, and log 2 is represented by B. Here we have A squared. A is represented by 1. So 1 squared is going to give us 1. So we have 1. Then minus, we have 2, A times B. That is 1 times log 2. That is going to give us log 2. Plus B squared. B squared is log 2. That is going to be log 2 squared. Okay, now, since this expression on the left-hand side is equal to this expression, we are going to represent this expression with this. Okay, so we will have K is equal to minus log 5 plus minus the square root of, so we will have this 1 minus 2 log 2 plus log 2 squared plus 4 log 2 divided by 2, the square root of, here we have 1. Okay, let us add these two logs together. Minus 2 log 2 plus 4 log 2. This will give us plus 2 log 2. Then plus log 2 squared divided by 2. Again, this expression represents an algebraic identity. Okay, if we have A plus B raised to the power of 2, this is equal to A squared plus 2AB plus B squared. So this expression is in the same format of the right-hand side of this algebraic identity. Okay, so what we're going to do next is to represent this expression in this form on the left-hand side. Okay, so here A is represented by 1 and B is represented by log 2. So we will have 1 plus log 2 raised to the power of 2, and this is equal to 1 plus 2 log 2 plus log 2 raised to the power of 2. We will replace this expression with this. So we have 1 plus log 2 raised to the power of 2 divided by 2. This power of 2 will cancel out this square root radical. Okay, so we will have K is equal to minus log 5 plus minus 1 plus log 2 divided by 2. All right, we are going to have two cases because of this plus and minus. Okay, case 1, we have that K is equal to, we will consider the positive first. So we have minus log 5 plus, open parenthesis, 1 plus log 2 divided by 2. So we will have K is equal to minus log 5 plus, we open the parenthesis, log 10 is equal to 1. So we will have log 10, then plus log 2 divided by 2. Here we have log 10 plus log 2. We are going to apply the addition law of logarithm. Okay, this will give us log 10 times 2. Okay, then minus log 5 divided by 2. Okay, so K is equal to log 10 times 2 will give us 20 minus log 5 divided by 2. So in the numerator, we will apply the division law of logarithm. So we will have k is equal to log 20 divided by 5 divided by 2. This is equal to log 4 divided by 2. We can express log 4 as log 2 raised to the power of 2, then divided by 2. This is equal to, these two will come to the back. We have 2 log 2 divided by 2. These two will cancel out. We have that k is equal to log 2. Recall that log m is equal to k. So the next thing we're going to do is to find the value of m, since we know the value of k. So we have that log m is equal to k. From our computation, we have that k is equal to log 2. So we will replace k with log 2. So we have that log m is equal to log 2. So the log will cancel out with log. We have that m is equal to 2. Remember, we are required to find the value of x, not the value of m. So recall again, x minus 5 is equal to m. Now that we know the value of m, let us find the value of x. We have that x minus 5 is equal to m. We will replace m with 2 and solve for x. So x minus 5 is equal to 2. So x is equal to 7. S is equal to 7 will satisfy the equation. We are going to stop here. If we proceed with case 2, that will produce the value of x as 5.1. Okay, and that is an extraneous solution. So we are not going to go ahead with it. Thank you once again for watching this video. If you find this video helpful and informative, please subscribe to my channel. And do remember to like, comment, and share this video. All the best.